we go. Today, we start simulation. Tuesday, we finish simulation. Next Thursday, we'll start forecasting. The following Tuesday, we'll might finish forecasting. We may not finish simulation. We may not finish forecasting. We may push everything to the 18th. If on the 16th we all agree that we got everything done we need, we'll maybe take the first half of the final then on the 18th, which would be just over these two chapters. Everybody understand what that means?
So basically the first part's just another quiz?
Yeah, but it will be like 45% of the final. The other 55% will be problems from every other chapter but these two then on the second day. Odds are we're going to need this day because of seasonal forecasting. When we get to seasonal forecasting, I got to slow way down. I try to explain it, the best I can, but some people it's just a lot to take in. To take the season out of seasonal forecasting and put it back in. So we're just plan on the final being the whole final at this point. All right. So now simulation. Here we go. Boom. You read all this at home. Yes, you did. Right here, and there. Boy, you read a lot. And we're here. Are you ready? Here we are. There's three major parts of simulation that you will use several times the rest of the semester. These three are the main ones. Uniform distribution, normal, known probabilities. Here is how you recognize them. Known probabilities is that somewhere in the problem, it's giving you the probabilities. There's a 30% chance it will rain tomorrow. There's a 20% chance it will snow, and a 30% chance there's clouds, and what's left? 20% chance it's going to be partly cloudy. There's a percentage being given to you to every possible outcome. And that's called known probabilities, which is what we're going to talk about in this very first example.
So in known probabilities, there's a probability that's expressed in the word problem?
There's a probability being given to you in the word problem. Well, and that's what it means by being known. All right, so you're skipping past all the ridiculous meetings that you had to come up with what these probabilities are, and they're known. Uniform distribution. The problem will always have the words about something like the data is uniformly distributed, or if it doesn't want, if the problem's not using the word uniform, it will say something like the probability of every possible outcome is the same probability. It's uniform. You get it? When you roll a die that has 6 sides, that's a perfect example of a uniform distribution. Whether you roll a 1, 2, 3, 4, 5, or 6, the probability is the exact same for every possible outcome. That's a uniform distribution. The probability is the exact same for every possible outcome. And you're not given those probabilities. You're just told a range, like, hey, we know it's going to be somewhere between 5 and 10, and every possible outcome is uniformly distributed or has the exact same probability. That's how you know then you're looking at a problem that's uniformly distributed. I'm going to tell you how to do that in a minute. And then there's normal. The third one is the only one that has a standard deviation in the story. Sound familiar? Remember waiting lines. There was no arbitrary on that quiz, so that would have been a good test on the whole standard deviation thing. So this is given probabilities. I'm going to put given percentages, which is the same thing. And this is outcomes have equal possibility, equal percentage. How's that? Given percentages, standard deviation, outcomes have equal percentages. And it may just be words. It's not saying each one of them have 1/6 of a chance. It will just say they all have the same probability of happening. Or they're uniformly distributed. Something like that. This is a perfect time to check right now. You ready? I want you to tell me which one of these three from what you've just been told that I'm reading to you right now. You ready? Blah, blah, blah. Blah, blah, blah. Here we go. In case customer, okay. I don't know if this goes to below or above. There isn't even numbers because I'm in a case. Here we go. The management of this corporation, I'm not showing you this on purpose because I don't want to give it away by looking at it. The management of this corporation is interested in using a simulation to estimate the profit per unit on this new product. Very common in real business is when simulation is done, when a company's thinking about going into a new product. Because there's a lot of times you're looking at $1, $2, $3 million to go in to launch a new product. The marketing behind it, if it's something you're making, the development of it, the molds, the setups, everything involved. So I've experienced being in meetings where the discussions are taking place rather than go for a new product. And it's all about let's simulate it first to see what kind of real risk we're taking. And that's what you do with a simulation. You're going to count. You say, okay, here's how we'll simulate how many customers buy our product. We can estimate that somewhere. Here's how we'll simulate what it costs for us to make the product. We know about what it's going to be, and we'll simulate all the possible costs we could have. Here we're going to simulate gross profit, or what may be advertising after that to subtract, or whatever it may be, and then at the end of this simulation for that one period, you'll have either a profit or loss. And then you have a couple of periods, and each period may be a full year even. And you want to do hundreds of them, because all the work on the simulations in that first row. You'll have this long first row doing this whole thing. Here's what labor's going to cost. Here's what parts are going to cost. Here's your overhead. Here's your marketing for this year. Here's this, that. You calculate net income. And then you copy and paste it in the next 999 cells below it. And now you just simulated that whole line 1,000 times. And then you write a little either if statement or a count statement, which you're about to learn, to count that last column. How many out of those 1,000 would say we're heading towards losing money? And then subtract it by 1,000 to get a percent. And this simulation literally is telling you, based on the information that you came up with all these meetings, the percent chance our labor's going to cost this, the percent chance our parts are going to cost this, our overhead would be this, this is how much marketing is probably going to cost us. All these things that are being simulated, when you do 1,000 of them, every combination of that's good, that's bad, will be worked out, figured out. Because sometimes your labor, we're at the high end of cost of labor. But our parts are at the low end. The next simulation, our labor's at the low end, and so's our parts. And the next one, they're both at the high end, or in the middle. It takes randomness into consideration on everything you said you don't have control over. How many will buy, how much labor is going to cost. Everything you don't have control over, randomness will figure it out, and then you look at that last column, and you figure out the percent. It's trying to tell you that you could be losing money. And a long time ago, we used to say, if that percent is anywhere above 10%, and I used to say 5, no, that's still too much risk in mine. We're talking about a couple $1 million. I'll be so cash, tight. This doesn't make sense. If that doesn't say more than 5% chance, if it says more than a 5% chance that out of those 1,000 we're losing money, we're not doing this. Or we got to figure out another way to bring it down to 5%. And then you start looking at, okay, how did we get these numbers for labor? Who could we talk to get these numbers more in line with what we need to lower the risk of losing money on this whole thing we're thinking about going into? What about the parts and materials? We talked to all the suppliers. What about a new supplier? Is there any way to get that possibility range of what these parts and materials may cost in order to get that probability, according to the simulation, because of those parts or because of that labor, in order to get that simulation to say to us, okay, now you have only a 5% or less chance of losing money, which means we have a 95% chance that we're going to succeed if we go into expanding this business into this new product. And having the odds that much in your favor, it's like, let's do it. 3 million, make it happen. And that's what simulation does. It brings you the confidence that you're not taking as much risk as you might have. And it allows you to say, this is what we got to do to get the risk out of this. Because, the first time you do it, you're going, oh my God, 40% chance that we're going to lose money. And then you have it look at all of those and say, what's the most you could lose? And it comes back that biggest loss. And you see $900,000 in 1 year. and you go, look, I know there's a very small chance of this happening, but just the fact that we have a chance of losing $900,000 in 1 year is just too much risk. And we maybe shouldn't go forward, or else we got a lot of work out of this, because I'm not going to be involved with a 40% chance of possibly losing money, and then one of them possibly being $900,000 in 1 year. It put the business out of business. It'd be crazy. That's what simulation does for you. It protects you from making a bad decision, and it helps you make better decisions, and it lets you key in on what would make it a better decision. So, are you ready? I don't even know what the question was. But let's get started. Here's the first example, and it's going to get you started with known probabilities so that so you can come up with how to do it. By the way, the key is called VLOOKUP. This is an Excel command that you would use if you say this story has known probabilities, and I need to simulate something using randomness. VLOOKUP. V, no space on this. VLOOKUP. VLOOKUP. And your Excel command would start with equals VLOOKUP, and then you got something there. That's what this first one's going to tell you about. Now, this company says, hey, we want to trade these shares of Dynagen, and we want to try to forecast or try to predict what will happen if we do the next trade. And so we're going to look at the last 50 trades and how much money was gained or lost per share on the last 50 trades, and then we're going to use that to give us the probabilities of what could happen on the next trade. So they went ahead with 50 trades and said, all 50 trades are in here. Either we lost as much as 3/8 of a dollar, I don't know how many pennies that is, someone can figure it out for me, or we could gain as much as half a dollar, 50 cents up. And here out of the last 50 trades are how many times each of these things have happened. Now, if this were a quiz, I would already have these converted to percentages for you, so you can say, known probabilities. And the next slide does that. It says, okay, now that we have how many out of 50, let's turn it into percentages. Well, hang on, I forgot what the first one was. 4. 4 divided by 50, okay, 8% of the time we lost 3/8 of a dollar, the share went down 3/8 of a dollar on the price. 4% of the time, what was that, 2 out of 50, or was it, anybody look at this one? 2 out of 50, that must be 8 out of 50 then? And look at the biggest thing that's been happening over the last 50 trades, which means there's possibly a 40% chance that our next trade would be no change in price, same price as that. And then so on, so on. We want to simulate what that next price will be, and the price after, and the price after. So let's, we got to decide which way we're going to simulate it. Is it uniform, normal, or known probabilities? And then you go, oh, we have the percents of the last 50 trades, what had happened. 40% of the time, in the last 50 trades, that trade had no price change, whether it went up or down. And then you go, okay, we're using VLOOKUP to simulate this. So the first thing on VLOOKUP is design your map. To put your map together, you have to assign numbers from 0 to 100. There's 100 numbers being assigned there, and the easiest way to do it is start at 0 and assign the exact amount of numbers that equal the percent that represents that outcome. Because there's an 8% chance of the stock price going down 3/8 of a dollar, we're going to assign the numbers 0 through 8. And then we're going to start at 8. Don't worry, it's the same number. And this one's 4%, so we're going to add 4 more numbers to it. We're assigning the next 4 numbers to 4%, or to the stock price would go down a quarter, 25 cents. Then we're going to start at 12, add 16 numbers to it, we get to 28, and so on and so on. Do you guys see how this is working? Okay, this is for visual, because this is how everybody, I need you to see this in your mind, but in reality, you have to use decimals. The exact same numbers, but it's 0.08, 0.08 to 0.12, 0.12 to 0.28. Nothing else changes. Look at it first, put it like numbers like this, and then add your decimals if this is what you need to do to know how to do this. You should always be finishing at 100, which would be 1.0. Just put the decimal in, move over 2 places to the left, and throw the decimals in. Excel only reads these when they're decimals. And that's why you got to do it. So really, you're assigning the numbers between 0 and 1 to each of these. But it looks like 0 to 100. Okay, everybody get it? All right. So I want to make sure you're getting this. Was that reading this problem? Is that where I was?
Yeah.
And did anybody answer it?
You never finished.
Thank you. That's where I was. And when I said where was I, nobody mentioned this. All right. Here's what you were about to see. Was this problem number 12 right here at the bottom? Hey. And I was going to say, you can look at it before I even read and tell me which one of those three would you use. There are no probabilities. You can see they're being given to you right there on those charts. And we have 1, 2, 3 different things that need to be simulated, and it's just a coincidence that they all are being we're being given the probabilities. That's not usually the case. One of them could be giving you the probabilities. Another one could be describing this somewhere up here because as a uniform distribution, somewhere between 20 and 25. And this one here could have said the mean is blankety blank and the standard deviation is blankety blank, and that would have been normal then. You could have all three of them on here. This is just a coincidence that all three of these you're being given the known probabilities. You need to map each one of them separately because the probabilities add up to 100% for each of these. 30, 45, 25, 100%. 30, 35, 25, 10, 100%, and 75, 25, 100%. 3 different maps going. I want to make sure you're getting this. So let's go to the first one right there. If I start at 0, and this is a cell right here, what would be in this cell as the upper limit for 10? The purchase cost ended up being $10. Point, thank you, I forgot the point. This was throwing me off. 0.25. So I'm going to start at 0.25 now. Wait, what is this representing? 10. I'm putting this in the third cell right there. The first cell, starting where I left off at 0.25, it's representing $11 cost. What is my upper limit here? No, come on, 45 to 25. What is that? Thank you. They said 7.2. Someone say 7.2. Am I hearing anything? I did tell you out here in the radio when the fan turns on, right?
Yes.
Make sure you remember that. All right, we got one more. 12. What do I start off here with? 0.70, and then all of these end with what? 1.0. 100 decimals. So this goes from 0 to 25, 25 to 70, 70 to 100. You ready? Excel goes do, comes up with 0.65. What numbers to bring it back? 10 or 11, $12 cost. 0.65. 11. Who said it? Thank you, Nick. You ready? He's saying that 0.65 landed between the 0.25, 25, and 70. So the computer says, there's where the random number's at. I'm bringing back, for this simulation, $11 cost for the parts, or whatever it is. All right? Goes again, 0.97. It brings back what cost per parts? You're getting it. You getting it? I want to make sure you're getting it. One more. Transportation cost. We got a 3 in this box, and we got a 5 here. I know this box is going to be 0, and I know this box is 1.0. What's that box? 0.75. There's a 75% chance. So we start at 0, go to 75, put the decimal there. 0.75 in this box, right? To 1.0, which would be 100. The computer goes, Excel goes 0.44, and it brings back transportation cost of how much? You get it, 3. Because 0.44 landed between these two numbers, so it brings back 3. How do you tell the computer to go up and look at this map and then bring back the thing that's to the right over here? Here's how you do it. You ready? You put equals VLOOKUP. That's the beginning. Once you realize that it's that kind of probability. Then you put parentheses. The very first thing in a VLOOKUP is you got to tell Excel, pick a random number. And we'll pick one between 0 and 100, or 0.0 to 1.0. And to tell it that, R, A, N, D, left parenthesis, right parenthesis, comma, no spaces there at all. This is R, A, N, D, parenthesis, parenthesis, no spaces. This is the command telling Excel, you pick a random number. Next, you want to tell Excel, once you pick that random number, where are you going to go and look at a map that I made somewhere so you can compare that random number to all the numbers. Where's our map? I just erased it. So you can compare it to all the numbers up here on the map. You got to tell where the map location is, and I'm going to call this, so everybody can see it, I'm going to call this row 4, this is row 5, this is column C, this is column B, this is column A on our Excel spreadsheet, okay? I would put words. Matter of fact, I wish I shouldn't be writing words. This first thing here is the upper left-hand corner of your map. So upper left. In this case, this would be where the 0 is on every map you make. If you start with the 0 in the top left-hand corner, like I've done with these examples, wherever that 0's at, that's the cell location here. And in this case, where's that 0? A4, is that correct? Don't forget the dollar sign. Dollar sign A, dollar sign 4, colon. You said to Excel, there's the top left-hand corner of my map. I'm using dollar signs because you're about to copy and paste it into the 999 cells below it, and you always want it to refer to A4 as the top left-hand corner. You don't want that to change, so you want to make sure to have those dollar signs. Colon, this is going to be the bottom right-hand corner of your map cell location, and it's always where, not where the 1.0 is, the right, just to the right of it, where the very last number you want Excel to bring back is at. So if you look at that map, you tell me what cell location would be the bottom right-hand corner of our map. C5. You got it. Is that a 5?
Yes.
Where that 5 is. So this would be dollar sign, I'm going to come over here just so everybody can see it. Dollar sign C, dollar sign 5. Is that what it is? Comma. The last part is you are now telling Excel, I told you where my map's at. It's 3 columns apart, but some people will put what you want brought back over here, 3.5. Then they put the 0 here, and the 0.75 here, and the 0.75 here, and the 1.0 here. And then these would be in column 1. I would make it to where the outcomes I want Excel will bring back in column 3, 1, 2, 3. So the very last part of your VLOOKUP is telling it which, out of the number of columns you're telling it exists, which one is the data you want brought back. In this case, I want 3. Column 3 has the data I want you to bring back Excel. And there's how you write that. Now, I want to give you a page number, because when you first do these, they're kind of like foreign language. Oh, wait a minute, what's this first thing? But I always refer back, I always looked at an example to refresh my memory a long time ago. When I found one that I know you guys, you see this? Okay. There's a great example. It starts on page 598. Now, look at this. Right here, in this box, there's a VLOOKUP being done. Right there. I want you to, now here we're getting into concept now. Because I want you to stare at it and say, what is this doing? What is happening here? Why is this simulation taking place? What's the objective of this simulation? What does it look like they're grabbing? Look at the titles. And what is it they're grabbing here? What are they simulating here? The what? The cost of labor. That's right. Now look at the top of your spreadsheet. Where is this Excel VLOOKUP looking to find this cost of labor? Anybody see us? Just give me any cell location. C14. C14 I heard, which is exactly where it's bringing it back from, right there. But look at the whole map now. The top left-hand corner is A10, you're telling me? Yeah. Okay, A10, so you're writing this VLOOKUP right now. Equals VLOOKUP, parenthesis, R-A-N-D, parenthesis, comma. You just told me dollar sign, I forgot already, A10? A, dollar sign 10, colon. Now what? What's the one? Yeah. What, say, it's, what's it say, C14? Yeah. Dollar sign C, dollar sign 14, comma. What now? B or C, or 3 or 2 or what? 3. You ready? Where do you get that? You ready? Yeah. Everyone's recognizing the map's right here. And the map is made up of 3 columns. Column 1, column 2, column 3. And you're telling Excel, the stuff I want you to bring back happens to be in column 3. This could be over here. And you'd have to tell it it's in column 1. And then the top left-hand corner, by the way, wouldn't have 0. It wouldn't have 0, 0. So if you wrote down the top left-hand corner is 0, 0, for this class it will be. But there's sometimes the 0, 0 is in the middle, and the top left-hand corner would be that 43. So it's out of the whole map, the top left-hand corner is where the numbers are starting in the top left-hand corner. For this class, it will always be 0, though, because I always put the data in the 3rd column. All right? So almost always, this will be, if you put a 3 there without even looking at it, odds are probably in your favor. Usually. You know, I'd play it. You gotta switch colors. How do we feel? We got D lookup down. Let's go back to the PowerPoint. See how this ends. So, we just mapped this. We got the random numbers. And if this were a quiz, it might say, okay, now look at your map. And by the way, if I said you're using your own map, that's fine. If your map's not perfect, you get points off on the map. But when you get to a question that says, now use the map to tell me, whatever, this will say what the price will be the next day, I'm going to base your grade on your incorrect map. If you're using it correctly, you're not going to get additional points off because you made a mistake on your map. You get those points off. Then your grade's based on how you interpreted your own map, even if it's wrong. Okay? Everybody understand where we're going here? If the number 21 comes up, and the price right now of the stock is $23, what will be the price at this trade? What was the random number? 21? 21. Random number 21 is the price of the stock, which is $23 right now. Is it going up or down or staying the same? The random number is 21. Look at the random number. Down. Down how much? 1.8. Random number 21, is that what it was? Landed right there between those two. In reality, that's 0.21 is the random number. It's between 0.12 and 0.28. And you go, okay, that price of that stock just went down 1/8 of a dollar. So now it's at $22.78. The next, stay there with 22.78. Next random number is 84. Match up 84 and tell me which way the price is going now. Up an 8. All right, good. What's the price of the stock right now?
0.
Back? No. We started at 23. We went to 20. So now we're back to 23. And this is the beginning of interpreting what's going on with Excel. This is what Excel does in a split second. It picks a random number at random, matches it up to the map you made, that's not in error hopefully, and then brings back this information. All right? So that's the first example. Whoop, whoop, whoop. Sure enough, the stock started at $23. The random number said go down an 8. The next random number said go up an 8. The next one said down 3/8 and so on. And after, how many numbers did they say? 10 numbers? After 10 numbers, is that true? After 10 numbers, the price ends up at $23.01, up an 8, after 10 trades simulated. Now this next slide, I would suggest, we gotta stare at it for a minute. No, there's nothing to suggest. Looks good. Confused with another one. This is just showing you Excel. Look at how it's 0.08, 0.12. You asked Excel to pick a random number, and where is it? Oh, it's doing it on its own. Right here, it's the first simulation is the price change. There's some random number that told Excel must have landed between 0.68 and 0.88, saying go up an 8. There's the new price. Another random number must have been somewhere right in here. Went down an 8, there's the price. It's simulating the stock price based on the information we put in there. Because we knew the probabilities, we put together a map. We used the lookup, and it's called known, I call it, I don't know the official name, known probabilities. There's that one, right? We got it? Okay, let's try another one. We're now looking at, let's do the uniform. Yeah. I'm about to tell you a formula for uniform. There's about like 4 different ones. They all get you to the same answer. I'm just going to show you what I feel is the easiest one. Right? Let's pretend this 5. All right, take care of that. Let's pretend this 5, this 10 in the story are the upper and lower ranges of something that's going to be uniformly distributed. The cost of parts is somewhere between $5 and $10 per item we make, and we know the cost of the materials and parts are going to be between 5 and 10, but we don't know exactly how much. And pretty uniformly distributed, evenly distributed probabilities that's going to be between those two. Now, you are not given the probabilities. You can't set 10%. You can count all the numbers between 5 and 10, divide it into 100, and set the numbers. But no, the price, the cost of these parts could be $5.52. It could be $7.91. There's many numbers between 5 and 10 that you'd have to divide into 100 if you're trying to break it up into known probabilities. Instead, let's say this is a column B on the spreadsheet, this is column C, and this is row 10, okay? Instead, I'm going to use words first, equals the cell location for the small number of the range, plus, which by the way, that would be, we're always going to use these two cells, so B, $B, $10, plus R, A, N, D, parentheses, no spaces, times, you've got to give the symbol for multiply on Excel, parentheses, the large number location, that 10, where's that at? So in this case, this would be $C, that's supposed to be a C, $10, minus the cell location where the smaller number is, minus, this is $B, $10. So let's do an example so you see this. Remember, this is 10, this is 5, that's 5. The random number is 0.5. You with me? 50%. Okay, 10 minus 5 means there's a range of 5 numbers, 5 pieces of whatever between them, times the random number, which is 0.5. So 50% of 5 is 2.5. Add it to the smaller number, 5 plus 2.5, 7.5 is the cost of parts for this simulation. Now Excel picks another random number, 0.1. Okay, 10 minus 5 is 5. 5 times 0.1 is 0.5, like 50 cents. Add it back to 5. $5.50 is your cost of parts for the second simulation. And it goes on and on with different, all kinds of different numbers, sometimes the same number. It randomly, like the real world, just randomly picks, and every number, if you copy and paste it 1,000 times, you will see almost every possibility that could come up between $5 and $10 for the cost of parts. Let's see it again. You ready? Right here. Uniform. Look at the formula up here. Equals I7. Now look, it's a little different. Slightly different. The multiplication's on the outside to the right instead of the inside to the left. That's the only difference. But operations, order of operations says you've got to do what's in the parentheses first. You've got to then do the multiplication, then you're going to subtract. So it doesn't matter if it's like that or like that. I7 is it's even using the largest number. I'm telling you, there's like 5 different ways, 6 different ways to do this. The largest number, so that's 100, and then it says minus I7 minus H7. 100 minus 80 is 20. 20 times the random number. Let's go with 0.5 again. So 100 minus 80 is 20, times 0.5 is 10, and then it says subtracted from the larger number. 100 minus 10, this simulation is going to be $90 for whatever this is. Let's use 0.1. I want to make sure you get this. 0.1. What's the first number? I7. 100. Minus the next parenthesis, what is I7 here? 100. Minus 80, and what did I say the random number was? 0.1 times 0.1, now you just look at math. 100 minus 80 is 20, times 0.1 is 2, subtract it from 100, the next simulation, 99. So 99 would be one of these. It's no matter how you set it up, whether you're subtracting from the largest number or adding from the smallest number, it will always pick something between the smallest and largest. And everything between, and once in a while, we'll pick exactly 80, because it'll be a 0 as the random number. And once in a while, 100. It will, when you copy and paste this 1,000 times, every single, there'll be 93 there like 10, 20 times, but 93.9, 93.4, 93 point, there'll be every possibility between 80 and 100 being simulated for whatever that is. Here it's being used in a real simulation. You gotta find it. Here it is being used in a real simulation. And as you look at this simulation, you should be able to recognize two of them now. Do you see a map up there? What cell is what cell is the top left-hand corner of that map that you see? Say it again. Oh, you can't see it. Damn it. Why? Okay. What cell location would be the top left-hand corner of this simulation? A10. You got it. Do you see a different kind of simulation going on up there other than known probability? By the way, what's the I forgot. What's the probability that the cost of labor is going to be $45? Now, you got to look into this. It's jumping right out of you. The probability that labor might cost $45. Give it to me. 40% chance. How did they get that? Okay, go ahead, Justin.
Upper limit minus the lower limit.
The upper limit for $45, which is a random number of 0.7, the lower limit is 0.3. The difference is 40 numbers. 40% chance that $45 be labor. It's showing me you understand this. You can read it. The probability of $46 in labor, 20% chance. There's 20 numbers there. Now, what's the other simulation you see? Uniform, which is, what is the largest number in the uniform distribution? 100. What's the smallest number? 80. And they're evenly distributed. Where is this uniform distribution being simulated in what cell in that top line of the simulation? You see it? Say it, Jordan, what line? I'm sorry.
Oh, no,
I thought you had it. Huh?
I can't see that far.
Caleb? Come on. 100? No. Shannon.
Wait, B21?
B21? I don't know.
No, it's C21.
Oh.
Well, it says here, the uniform distribution is parts. You come down here, and it is C21. Wow. Right there. What would make this work? What would make that work? You ready? Use any formula you want. Equals. What am I putting right here? To make that uniform distribution, look up there and bring back some number between 80 and 100. You're looking at the cell right now, C21. Say it again, E8? E8, so I'm going E8, let's confirm it. E8 is the smallest number. Looks like we're using this formula maybe. E8, I'm going to put dollar signs in because they really should be there. Plus or minus?
Plus.
Plus, because it's the small number. What do you want to put next?
Rand.
You don't have to though. You could start with parentheses, then the rand. Either way it will work, but R-A-N-D, parentheses, what now? Very good. Because I can't tell you how many people are going to forget that multiplication symbol right there. And just put it right next to something instead. What do I get next? Parentheses, now what? E what? Taylor, what did you say? Or was it, who said it?
E9.
Oh, okay. You say it at the same time. E9, now what? Minus $8, $8. You did it. You looked at this and you said, okay, parts, uniform. This is a quiz question. This is exactly. You're going to be asked several questions. You're going to be given a simulation like this, and in the first question might say, give me the Excel entry that you think belongs in C21. You're going to analyze this and figure out what is C21 doing. Oh, it's giving me the cost of parts. And then you look up here. Okay, labor. This is demand. Parts. Oh, parts are uniform. We only got two numbers there. And look at the space, the cell location of those two numbers. And then you got to give me this. You can give it to me as the small number first, like here. You can give it to me as the large number, subtracting instead of adding. You can put the rand on the outside, doesn't matter. As long as it's doing, simulating parts, and you understand that it is right there in that cell. It'd be like right now me asking you, what's in cell D21? It is a normal distribution. What he's saying is D21 is looking at demand. Up here, demand's right here, normal distribution. You're being given the mean and the standard deviation, and I can tell by the way everyone's packing up. Oh, stop. What are you, crazy? Here we go. You ready? And now let me tell you how this is done. This is the third one. That's all you got to realize is there's three. This isn't the hard part, coming up with what's there, what's there, what's there. The hard part is you're looking at a story and be able to tell me, should you be doing this, creating a map? Should you be creating a uniform distribution thing or normal? That's going to be the part you need to focus on as we talk about, especially Tuesday when I start reading some of these, and you got to tell me what you would do, which one you would use. Okay, we're going to now demand. The formula for normal, you know, if I come to highlight instead of writing it up here. This is what it looks like. Equals. Use N-O-R-M-I-N-D, normal inventory, whatever. Parenthesis. The first cell location is you're telling Excel, pick a random number between 0 and 1. R-A-N-D, parenthesis, no spaces, comma. Then you get the cell location where the mean is for this normal distribution. It says right here, demand is normally distributed with a mean. The story will say, marketing has reported to us that they think they're going to sell on average 15,000. It is normally distributed around 15,000 at a standard deviation of 4,500. You key in on those words, standard deviation, and you go, oh, this is normal distribution. And you've been given three formulas. It's either VLOOKUP, it's either that formula in all its versions, or this one, which is equals N-O-R-M-M-I-N-D. And that's it. 1, 2, or 3. And then you're going to say, okay, this is that third one. And you're going to be asked to write that formula, and you're going to go equals normal IND, parenthesis, R-A-N-D, parenthesis, that's how you start all of them. They all start exactly there. Now the difference is the cell location where the mean is. It could be anywhere. You got to look up here, and comma the cell location where the standard deviation is. And you'll notice in this demand, it brings back all kinds of numbers around 15,000 items sold. Does everybody see this? Now, where we're heading is not only do you have to understand how a simulation is put together, but you then got to use the simulation to figure out whether there's going to be a loss or profit. Look at the information. Let me go back up a little. Let me make this a little smaller so you can see everything at once. But look up here, and you go, okay, we know profit from accounting is going to be revenue minus expenses. So we got to figure out, using everything we have here, how to have revenue minus expenses. So you look at the top of there where all the information is being given to you. You tell me, do you see anywhere that would tell us how much revenue is for every one of these items we're going to sell? Where is it? C3, $249. So we're doing a simulation. We went ahead and simulated that labor is going to be $45, which is too much. Parts are going to be $90. That's far too much. We're going to have our demand for the first year is $14,470. How do we figure out revenue? Hit me, Dick. $249 times the demand is revenue. So we're going to go equals, where's 249? C what? 3. $sign C, $3 times, here's our revenue, I'm putting in parentheses, cell location where demand is. Do we use a $sign? No. Because we want it to use different demand for every simulation, so don't use a $sign. You say D21? Yeah. D or D? D. D as in dog. 21, parentheses, minus expenses. Hit me with, name an expense you see on there. Direct labor. Here's our labor right there, but how do we change that 45 to represent labor for the whole year? Nick, hit me again with the same answer. What? Do not hesitate.
Is it 45 times 249?
Again, it's
45 times 14, 47.
There we go. You give me a heart attack. Whatever demand is predicts how much our labor is going to cost, how much our parts are going to cost, and our revenue. Those are all variable numbers that are directly related to how many we sell. So now we're subtracting our labor, which is B, is that A or B? B, which is B21, no dollar sign, times D21, no dollar signs, minus, we got more expenses. C21, now we're going to do parts. So C21 times D21. We have any more expenses related to profit for this company? Revenue minus labor minus cost minus what? I'm giving it away. Overhead, which is what cell location? I see overhead up there. Administrative. Oh, we got advertising too. Oh, there's huge expenses. Minus, so we gotta go minus. Now, what is that? C4. Dollar sign or no dollar sign? What'd you say? Yes, because it's always going to be C. Is that C4? Yeah. Dollar sign C, dollar sign 4, minus dollar sign C, dollar sign 5. That's it, right? So we got labor, parts, administrative overhead, and marketing, and that will give us our profit. Are you ready? All right. You did this simulation 500, 1,000 times. All the work is in this first row. Now that we got that done, copy and paste. Copy and paste. Or do them all at once. Copy and paste. And all the work's in the first row. Everybody can copy and paste. Let's get to the bottom though. You ready? If we go forward with this product, what percentage chance that we could lose money and that we need to meet again and figure out how to change things? What percent chance is it that we would lose money? Did anybody see it?
27.
Yeah, it says there's 38. This is where we're heading. I need you to learn tell Excel to go look at all these and count how many said we're losing money. How many did we do? We did 500 simulations. 38 of them are losses. And by the way, I'm going to run this again and again and again and again, and I'm going to figure out the percentages of every single time so I have a clear understanding of what the average percent chances of us losing money. And it happens to be 7.6%. If, from what I told you, when I were at that meeting, would I be saying, let's go for it, yes or no?
Yes.
No. I am not that kind of risk taker. Not at all. Not at all. And this is why I sleep better than you. All right? Because I protect the nest egg. I protect it. All right, I'll see you guys on Tuesday.